All right, let's get started then. Welcome to day 2 of BCP. Glad to see many of you are still here. Today we can actually begin to get to have fun with JavaScript and actually do some stuff rather than just space things out and correct spelling mistakes. I know you're all very excited to learn how to actually build things. But before we jump into the lecture, I always like to do a little pre-lecture where we do some housekeeping. I will take questions about anything, and then I like to give you a few problems that demonstrate where we're headed. So as we move into the slides, you kind of already have a visual and can tackle other questions early. So first, over here in this REPL, I saw that there was a question in the Slack channel, and a few people had reached out to me directly. If you have a question that you need a response from the instructors, if you drop it in the Slack channel, I'm not necessarily going to get notified while I'm at work. So if you want it in the Slack channel, be sure to tag the instructors directly, because that will force a notification to my phone so I can respond. Else, like some of you have done, you can message me directly and I will definitely see that as well. Then just to talk a little bit more about LearnDot, when we're inside of a workshop and you're on the workshop screen over here, it's really easy to miss, but there's this little blue link here that says you can download the whole course. If you click that, it will have all of the slides for the course as well as all of the future workshops. So you can download that entire folder and have it on your laptop and be good to go. But these links will be used to open it up in CodePen as well. And as far as pre-reading goes, there were some questions if there were any pre-reading. But basically, when we go to a workshop, what I mean by pre-reading is that it's always going to be this first little tab over here. Sometimes we'll have links to eloquent JavaScript or other articles to actually read, but in today's case, we just had lecture videos. That's still the pre-reading. So there might not always be literal reading, but there will always be some content on the next day's workshop under this first chapter here. And thank you very much for those of you who uploaded the photos to LearnDot, but I'm still struggling to learn all of your names, and it would greatly help me out if you have the chance to put those photos up on LearnDot. So environment, CodePen. Did we have problems figuring out how to save the CodePens yesterday? I know there were some questions, but I don't know how the rest of the class did. Basically, once you open up the problem in CodePen and you're logged into CodePen, that's the important part, you'll want to click the fork button, which basically says, hey, make a copy of this, but make me the owner. And that's your starting point. You'll work off of the fork. And then CodePen also has that little button that has a heart on it if you're logged in. You can click things a few times on that heart. And when you go to your profile, you'll be able to sort it by your most liked CodePens, I guess. So I don't know if we need the visual for that, but let me know if you have any problems figuring out how to access your previous work in CodePen. Any questions about CodePen or the REPL environments? Again, I prefer to do my work in REPL and move it back over to CodePen because it's kind of crowded, but you just have to figure out what works easiest for you. And I highly encourage you to tap into the monitors and use the wires in front of you or bring the adapters you need, because that extra screen real estate really comes in handy. So any questions on anything so far about the course, about the content, where we're headed, anything I can clear up? No, very quiet, no questions. All right, let's jump into today's pre-work then. So, just as I mentioned yesterday, we don't want to repeat ourselves in code. We want to write something once and have it be able to work no matter how big the inputs are. So what we're covering today are the tools that allow us to repeat code for dynamic inputs. So to start, let's say that I wanted to console log out all of the numbers between 1 to 5. This gets pretty tedious if I was doing it like this. And that would be a lot of work. And then it sucks if my manager comes to me and says, hey, actually, we didn't want to just count 1 to 5. We wanted to count 1 to 100. Now I've got a problem and I got to type this out 96 more times, and that's no fun. So what we want to do is we want to write a for loop where we're going to isolate the logic that we want to repeat, which in this case would be the logging of the number. And then we just want to set that code to do that for every number between 1 and 100. So In JavaScript, we have something that's called the for loop, and the skeleton looks like this. Basically, when we hit this for keyword over here, there are a few rules that we're going to plug in, and it's going to apply the code in between the code block for as long as a certain condition is true. And every time it does that, it's going to make some change. It's going to increment or decrement some number. It's going to check that that still satisfies our condition. And if it does, we're going to repeat the code again. So this for loop takes 3 statements that are sort of the recipe for how a for loop should work. And the first statement will immediately be run as soon as we hit the for keyword. And that's often used to initialize an index. So in this case, if I'm saying I want to count from 1 to 4 or 1 to 5, then we want to start at the number 1, and that's going to be my first index. So in here, I can say let index, this variable that I'm going to use to iterate, let's start that out at 1. And that's my first statement, so I'm going to close that off with a semicolon. The second bit of the for loop says it's some condition that's going to be run after each code block. And while that's true, we're going to do the stuff inside of the curly braces. So in this case, I want to continue repeating the instructions as long as the index is less than or equal to 5. So we're going to start at 1, and we're going to do it for 1, 2, 3, 4, and 5. And as soon as that thing is greater than 5, we're going to stop, and we'll continue outside of the for loop down here. So that statement over here is going to be while the index is less than or equal to 5. And I'll close that off with a semicolon as well. And now the last statement that the for loop takes is the statement that it will run after every code block execution. And so in the case that we have some condition here and we have some starting point, the updater statement should be used to get us to a point where we will eventually break out of that condition and not have an infinite loop. So in this case, all we want to do is increment the index after we've done whatever work is inside of this for loop. Any ideas on what work I actually want to do inside of this for loop? Yes, Ryan, what should we do? Console log I? I changed it up on you. Yeah, I'm using index here.
Oh, sorry. Yeah.
But yes, exactly. So in here, it's good that we want to console log. And generally, it's always good that we put some sort of label with our console log. So when we have a billion console log statements, we actually know what data it's supposed to be. So console log actually takes multiple arguments. So the first one I'm going to say is current number is, and then I could put a comma to separate the next argument. And in that case, we're going to do what you said. We're going to log out the index here. And when I run this, we see in the REPL the output of this program. Basically, anything in white is logs that went to standard out, or what console log writes its messages to. They'll all be collected in the order they ran over here. And the green is referring to whatever the last line of code actually evaluated to. And in this case, that was probably the final console log. And console log doesn't evaluate to any value in particular, which is why we see undefined. So if I just drop 100 down here, the final statement that runs is evaluating a value from here, and that value is just 100. So that's all that the green means, but we'll keep talking about that. Don't worry about that green undefined. Instead, right now, we care about making sure that we correctly incremented from 1 to 5, and it looks like we did. So real quickly, again, this is some starting point and some set of data that's only going to exist while we're inside of the for loop. So to demonstrate that, if I try to say what is index down here, we get over here index is not defined. We'll cover scope more in a couple days, but basically this piece of data only exists while we operate in between the curly braces. And that's part of why the horizontal alignment is so important, because to the eyes, I can tell that this thing only exists inside these braces, and it lets me know a little bit more that this should not work. So the three pieces are our starting point, the condition that will be checked, and if it's true, we'll run the code. After we run the code, we're going to do this operation, which moves index from 1 to 2 to 3. And eventually, when we hit 6, this will evaluate to false, and we won't see a log for 6. So just to demonstrate how important that incrementer is, if I instead accidentally made the index decrease, the number is always going to be less than 5, and the computer is going to freak out and lock up for a second until JavaScript is smart enough to realize that, hey, we've got a potential infinite loop. I don't want to freeze your computer forever, so JavaScript just turns off the program, and it throws this error down here. Does that make sense? The whole lecture is going to cover this more in detail. This is just kind of where we're headed. So another way that we can do a loop is with a while loop. And the while loop works a little bit differently, but all three pieces that we just mentioned will be present in the while loop. You just kind of have more freedom to put them where you would like. So the while loop looks like this, where we have the keyword while, and then we're going to have some condition in here that will be evaluated. And when that condition is true, we're going to execute the code block. After executing the code block, it checks the condition again, and we'll repeat that process until the until the condition fails. So in this case, we need to define another number. Let's use num this time and say it's 1. And our condition is going to be, well, num is less than equal to 5. That's pretty similar. And the work that we want to do is to log out what num is. So I put my label there, I put the comment, I pass the second argument. Both of these will be logged out. And the trick here is that the while loop, there's no spot that forces us to update this number. If I run this, we get an infinite loop again, because 1 is less than equal to 5. We log it out a bunch of times, and we continue doing that until JavaScript turns off the program, because number is clearly never going to end that condition. So it's easy to forget, but inside of this while loop, we have to make sure that we do the incrementer ourselves. So over here, after we log out the number, I'm going to increment it, and we get the same exact behavior as with the for loop. So those are two ways that we do looping in JavaScript, and the output is the same as long as you set it up correctly. And you kind of have freedom as a developer to choose which you prefer, and it depends a little bit on how you want to access your data. In this case, if the num was created outside of this while loop, I still have that number at the end. Do we have any ideas what the number will be down here on line 32? Nick? You said 1. Anybody else? So it's actually 6. Now this piece of data is saved out on the global scope, and we're going to cover this again in a couple days. But number definitely exists, and any changes to it are going to be persistent. So when we come in here, we log out num at 1, and then we say, hey, go find that number variable, whatever integer it is now equal to itself plus 1. So this right here is shorthand for the same as saying num is now equal to whatever it currently is plus 1. So we logged out 1, 2, 3, 4, 5, and after we logged out the 5th number, we did increment it to 6. Then when we went and checked the condition, 6 is not less than 5, so this value here evaluates to false. And we jump back to continue processing our code from the end of the code block. So when we come down here to log out num, we see that num is now 6. With the for loop, we wouldn't be able to get access to that index outside of the for loop. So that's a difference between the two, but when to use them will become more apparent as you gain some more experience. These are just two ways that we can begin to repeat a bit of work for now. So this isn't exactly the most useful program. Often in programming, we're going to have a set of data, and data can be any size, and we'll probably need to iterate through that data and do some other work. So in an example that somebody is giving us a string of characters, we might want to check all of the characters and look for a certain character. rather than just count numbers, we can set up a loop here, and we want to loop through all of the characters of a string. So we can say let alphabet equal A, B, C, D, E, F. And now we want to set up a for loop that's going to loop through each of these characters and print them out separately. So we'll do the same thing where we're going to start with an index, but in this case, we want the index to start at 0. Because in programming, if we have a list, programming is 0-based, which means the very first thing in a list actually counts as being in the 0th spot. To demonstrate that, if I want to look at a specific index of this string, I can access the string and use these bracket characters with a number, and that number will point to a specific index, and it will evaluate to that character. So the character that's in the 0th position of the variable alphabet is going to be what shows up on this green line, and that's A. So what we want to do is we want to have an index that's going to increment until it's greater than however many letters are in alphabet, and then we can use that index to access each one individually. So we can start that index at 0. And does anybody have any ideas on when we should stop? How do we know when we've gone outside of this alphabet?
IVX is less than or equal to length, not IVX.
Okay, so very close, but yeah, with this string, we have a special property that exists on that variable that JavaScript gives for us. And what I mean by that is that we could type alphabet.length, and we see that that evaluates to 6. It's telling us there are 6 characters in this string. And so if I use that as part of my condition, I'll be able to handle this string no matter how big or small it gets, and I don't need to edit my code. But there's a little gotcha here. Exactly. So what is the last index of this string? It's 5, yeah, because we start at 0. So 0, 1, 2, 3, 4, 5. So we want to go while we're less than the length, because if we try to access the character at the 6th index, there's nothing there, and we're going to get undefined. So that will get easier in time, but it definitely throws off a lot of beginners that programming is 0-based, whereas the length will actually have one additional number than the actual final index. So we want to continue while the index is less than alphabet.length, because we know this is going to evaluate to 6, and we know the final index we care about is 5. And what can I do to increment this thing? Index plus plus. And we can say that we want to access the data that's stored at alphabet, but more specifically, we want to go to a specific index that we're looping through. So in this way, I can run this code and see that we correctly access every single index there. Now the reason this label is important is because if I didn't have this label here and I saw A, B, C, D, E, F, I might assume this undefined came from somewhere else in the code. And it might look at first glance like my loop actually looped over all of the characters. But with this label, I can now visually see that inside of the for loop, we thought a character is undefined. And that's no good. We don't want to access that character. And this label makes that really obvious for me to see. Do we have any ideas on how we could possibly loop through this alphabet backwards? I'm sorry? Okay, so our index, we should start at length minus 1, which should resolve to the final index. What else needs to be changed in here? What was that? Yeah, so we want to decrement. Would this run?
IDX, the second statement, IDX is greater than 0.
So just greater than? Greater than or equal to, yeah, because we still want to log out while we're at the 0th index and get that first character. But as soon as we go into negative numbers, we don't care anymore and we want to break out. And something is still wrong here. Thought I did that. Thank you. So there we go. We log it out, and with our label, we see that we correctly looped through the string backwards. Now, just to add one more step that shows how this can be used, let's pretend that we wanted to have this thing in reverse. So I'm going to make a piece of data called reverse string, and I'm going to start it out with this empty string. We know that we can access each character here with alphabet and plugging in the index. Does anybody know what we can do inside this code block to build up the reversed string? Exactly, so we just added a little bit more work to our for loop, and we're saying, hey, every time we do work, reverse string should now be equal to whatever it currently is, plus this additional character. And all it's going to do is smash them together. So at the start, we basically have empty string plus A, or plus F, and this turns into F. Then on the next iteration, when E is the character, we have F plus E, and we get FE when we smash them together. And because I declared this thing outside of the for loop, we can access it inside of here, and those changes are persisted when I want to access it again out on this global scope all the way to the left. And we can see that the reverse string is correctly reversed. So that's a quick dive into these tools and how they're used. Do we have any questions before we move on to the slides? Okay, so one, I'll show you a do-while loop, and I think we will see them in the lectures, but I think they're not as useful, which is why I didn't overload you with them right now. And your second question was, like...
Just like the pre-reading went over some stuff that I didn't see on the syllabus.
Okay, so what do you mean by the syllabus?
That was like one. Oh.
Like, do you have a breakdown of what's in the lectures? Is that what you mean? Like, you didn't see it in the slides, but it was mentioned in the pre-reading? Yeah, so I would encourage you that if you see anything you don't know what it does, to give it a Google and to be intellectually curious, because the more that you can learn and at least be aware of, you give yourself more opportunity to grow and to add additional things to your toolkit. That being said, if you see something and you try to give it a Google and it doesn't make sense, don't kill yourselves over trying to wrap your head around it. Like, you can always revisit that knowledge, and once we learn some other things or you get more comfortable with the normal while loop, a do-while loop will make a bit more sense. So I think it's always great that if you see something you're curious about, try to give it a go to find the answer yourself, but don't force yourself to struggle through it. We'll cover almost everything you need to know to get started with JavaScript and be in a position that you can learn everything else. Sound good?
You guys can send me an email too. Anytime. If you have a question that you're stuck
Yeah.
on or something like that, just, if Google's not helping you, I will.
Drop your email along in Slack as well, so they see you and can message you. Thank you. Yes. Yes. Yeah, so in this case, all I was specifically looking to do was print out the numbers between 1 and 5. and use the number directly, which is why I just started with 1 and I went up through 5. But in the case down here, we wanted to access individual characters in that string or that list of characters. And how JavaScript and most programming languages work is that if we plug into these brackets a number on a variable that's a string, it corresponds to a certain index of this string. And to be able to log out this A character, we need to access the 0th index. So A is the 0th index, B is the first, and then F is the 5th. Yeah, so it depends what you were trying to do back here. I don't follow. Okay. If you wanted to log out the 0, then yeah, we would want to start that index at 0. Yeah, if we... If I had my numbers in a string like this, and I was going to access them with an index, then yeah, the 0th index of this string would have been the character 1. But because the numbers work for me as numbers, it was easier for me to just start with the number 1, go up to 5, and just log the number out directly rather than have them in some list somewhere. But if we wanted to loop through 0 to 5, we could just start the index at 0 and go up through 5. Kirsten.
To clarify, so it's a string is like the 0th position in the way that European house floors work, like the ground floor is 0, and to get 1 you have to go up.
Exactly, that's correct.
So it's a string is why it's 0, and anything else it can start at 1. It's a number already.
Yes, because in the case of these numbers, I wasn't necessarily looping through a set of data or accessing a list. I was just holding one. I'm sorry?
When it's a string, always.
Yes. Yeah, in this case, I was just holding one thing that I said is a number, and I called it IDX. And its value was 1. I just wanted to log out its value. So when we started, its value was 1, and I logged out 1. And then I incremented it, and its entire value was 2. So I could just log out the value again. And that value was just IDX. Whereas down here, I'm not logging out the index. I'm plugging the index into that list of characters. And that's translating to a specific character.
Also, to clarify, is the reason that it's adding on, smashing them together, plus equals?
Yes, the plus equals is shorthand. Whoops. For if I said this, reversed string is now equal to reversed string plus the character that's at the index of alphabet. And we're going to cover that a bit more tomorrow when we dive deeper into data types. So I'll come back to the do-while loop if we don't see it in the slides. All right, Ryan? Any other questions? Yes. Yeah, so the order in here doesn't matter too much because every time we run this code block, this is going to be logged out to the console, and adding to the reverse string had no effect on what we did here because both of them just use alphabet index, and the console isn't necessarily using any of the data in a reversed string that would have been updated if this came before it. Yep, so all of these up here are generated in this for loop. When this for loop is done, the computer resumes following our program from the end of this code block. And so this is always going to happen after I've built up the reversed string inside of this code block. And the order of when I added to the string and when I logged out the current letter doesn't affect this at all. All right, moving on to today's slides. We are going to talk about the do-while loop. We're going to break down the for loop a little bit more, and then we're going to talk about these certain keywords that give us some additional functionality to be flexible inside of our loops. After that, we will go over some debugging concepts and how to read an error message. So, while loop, it requires 3 keywords. It needs that while keyword, and you'll notice that any reserved word in JavaScript will be highlighted in blue. And what I mean by that is that the JavaScript programming language has said, hey, nobody who uses JavaScript can ever type these characters alone, because while means something special to JavaScript, and that's why it's showing up in blue. If I went to name a variable and I tried to store some data in it, we see that the variable name is blue, which means that it belongs to JavaScript. And when I try to run this, it's not going to let me do that, because when it sees the while keyword, it's expecting this type of code to come below it. It's not expecting an equal sign here. And so that's why we get over here, it says unexpected token. And this is saying it happened on line 27. So if we look at this, the 27, we come over here, we see, yeah, this blue while is a problem. So that's what they mean when they say the while keyword. Any JavaScript keywords that you can't use will show up in blue or whatever color is in your editor. Then it takes a conditional expression, and that's the thing that came in those parentheses. And it says that that expression, when the computer runs it, it should evaluate to a Boolean value. So far, we've only used less than and greater than operators, which work just as how you would think in English. If something is less than something else, that expression will be true. And if something is not less than whatever number's on the right side, that expression will evaluate to false. And so what I mean by that is you can imagine that every time JavaScript comes and it checks whether number is less than or equal to 5, it basically temporarily plugs into here whether it was true or false. That's the final value of the expression. And then if it's true, it does the code block. And if it's false, we exit. And then the final piece is a block of code, or what comes in between these curly braces. And what do we do when we're inside of curly braces? We indent, right? 4 space characters or 1 tab, and that should visually show us that, hey, this code only will be run inside of this code block. So the block of code will run over and over as long as the conditional expression evaluates to true. So we have another similar example here. We're saying, hey, get me some space in the computer for something that I'm going to call count. And its current value is the numeric integer 3. And we're saying, hey, while whatever the value of count is, if it's greater than or equal to 1, we want to do the work that's inside of this code block. So we're going to log out whatever the current value of count is. And the important thing is that we have to remember to decrement it. Again, this is shorthand for saying count is now equal to itself minus 1. And when we run this code, count will be 3. 3 is greater than 1, and that's true. So we log out that the count is 3. We decrement, and then it will plug the new number in, which will be 2. 2 is still greater than 1, so we can log that out and repeat the process. Once count hits 0, it's no longer greater than or equal to 1, and we'll continue down here, and nothing else happens. Yes? Yeah, so this specific example isn't really a good real-life example. It's to demonstrate what's actually going on. So the purpose of this program is to count the number down from 3 to 1. So they're starting the number at 3, and they want to do this log every time the number is greater than or equal to 1. So the cases where it's true are when count is 3, 2, and 1. And once we decrement to 0, we don't do any more work. But yeah, this isn't really that useful in real life. This is just a demonstration of how we could use the while loop. A real life example would be maybe we take an email address from a user inside of an app, and we want to check if the email is a valid email. And we could say, hey, while they didn't type in a valid email, go hit them with a pop-up that says type your email address in again. And only when they put in a valid email will we continue and do other work on the page. If you keep typing in random characters, it's going to keep telling you, hey, that's not a valid email. And that will continue back and forth. So we can plug anything into the parentheses over here. Tomorrow we're going to talk about how different data types are converted. Like if I just plugged in a string over here, if I just plugged in the characters CHRIS, what would JavaScript do? And so we'll talk about that tomorrow, how it turns these expressions into true or false values. But in this case, we're just plugging in the value false. So when it comes over here to evaluate if this is true or false, it doesn't have to do any work. It has a value it's looking for. The value is false, so it's not going to go into the code block. And when we run this program, absolutely nothing happens, because that condition is always going to be falsy. False is a falsy value. And over here, when we plug in the value true, and we have no way to change it at all, this line is going to run over and over again until JavaScript steps in and turns off the program. But you'll see this mess before that happens. Yes?
Just quickly explain saying false is a falsy value.
Yeah, so we have different data types in JavaScript. And we see that over here, this is an integer, and it's a piece of data. JavaScript recognizes it with the green value on it. But we also see that false and true are turning blue. They're reserved words inside of JavaScript. And what they're indicative of is this category of data that we'll cover tomorrow, but it's known as a Boolean. And it's a Boolean type of data can only be true or false. So when we plug an expression in down here, JavaScript has a set of rules on how to evaluate this thing and determine whether it's truthy or falsy. And it's basically going to evaluate it, and based on if it's true or false, we either do the code block or we exit. So we can plug values anywhere into JavaScript. We don't have to only plug calculations. But any calculation we do, like, hey, is the number less than 5, will eventually result in a single value. And so less than equal to 5, when the number is 1, is going to result in this blue, true, Boolean value.
Correct me if I'm wrong, so falsy is basically a synonym of false. One's not an umbrella of the other.
Yes, so these are like the raw truthiness.
Okay.
If we want to know if something is true, it gets converted under the hood to a Boolean value. And JavaScript has a list of rules that tell it when something is true and when something is false. So we're going to cover that completely tomorrow. But to do a quick example, let's say that we have this string here, and it's an empty string. And if we wanted to know what its Boolean value is, I can call this JavaScript function that's in purple. It tells us that's something JavaScript already gives us. I don't have to define it. But basically, this is going to tell us, let me just comment this off down here. This call here is going to take whatever data type is inside of this and tell me if it's a true or falsy Boolean when it gets converted. So in this case, empty strings are falsy. Whereas if I type any characters into here at all and it has a length, it's going to evaluate to true. So you can imagine if I just plugged str into the while loop, it's going to do the same conversion to the true or false and then decide whether it should do the code or not. So JavaScript has all sorts of different rules to determine how to convert a string to a Boolean or how to convert a number to a Boolean, and that's what tomorrow's lecture is going to cover.
Thanks.
So it's a little bit tricky at first trying to explain all these concepts when we can't explain them all at once. So just bear with me, and we're going to fill in the gaps as we go, but that's a great question to have. If it confuses you right now, we cover it more in detail tomorrow. So that true value is always going to stay true. It's not a variable. It's never going to change. It's literally the value true. and this loop runs forever. So over here, we have a similar problem. We start the count at 3, and while the count is greater than 1, we want to do some work. And the work we're doing is just to log out what the count is. But with the while loop, we have to remember to eventually break that condition. And we're not doing anything in here that's going to bring the count to eventually be less than 1. So this is another infinite loop. Now the for loop, however, is a little bit more organized. And you can imagine that the English version of the recipe looks a little bit like this. We've got that for keyword that will show up in blue, and then we're going to have 3 statements inside of here that are separated with semicolons. So when it first hits this for keyword, it's going to run whatever statement or expression comes before the first semicolon. And that's known as the initializer. That's when we said, hey, let the index be a number that starts at 0. And that's how we started our loop through the string. Right after it does the initialization, it's going to run the condition. And the condition can be any code we type in there that eventually JavaScript is going to convert it to a true or false value. So before, we were very easily just saying, hey, is the number less than or equal to the length minus 1? And that thing evaluates to true or false. And if it's true, the for loop will do the work that's in between the block. And after it's done that work once, it will finally run this final expression before it does another check. So on the final expression, we need to make ourselves get closer to eventually break that condition. So in the case that we looped through the string, we incremented the index because we said we wanted to go from the first index, or the 0th, up until the final character in the string. So after we logged them out, we needed to come up here and make sure that we incremented that index, and eventually that index will be greater than the string. So after we do that expression, it checks the condition again. If the condition evaluates to true, we're going to run the code and then run the final expression again. And that process repeats until we eventually break the condition. So the block of code will run over and over until the condition eventually evaluates to false, and that's going to be caused by this final expression. Whereas in the while loop, there's no spot that forces you to put that increment or decrement or anywhere. You have to remember to do it inside of the code block. Do we see the difference between those two loop setups? Yeah, I would recommend that the for loop might be a little bit easier at first because it kind of forces you to think about all 3 of these pieces and analyze it correctly, whereas the while loop will kind of let you forget and drop off the final expression, and your code's going to run forever. So the initializer is run first and only once. It's often used to define a counter variable, like we made that index and started it at 0. Then before every iteration, before it ever hops into the code block, we're going to check that condition to see if it's true. And if it is, we're going to execute the code in the code block, and then we'll come back up and we'll run the final expression. So in this case, another similar example, we're saying, hey, let's just start with some number that we're going to call I, and let's start it at 1. And as long as I is still less than or equal to 3, we want to log out that I is along with its current value. After we do that, we increment I to eventually get above 3, and we'll break out of the for loop after logging these 3 out. Question, Ryan?
Yeah, if the initialization doesn't fit within the condition, will it still run on the
What do you mean if it doesn't fit within the condition?
condition is I is greater than 10 and you start with I5? Will it still run a single iteration?
Okay, so it says that we run the initialization first and only once, and then before every iteration, we're going to check that condition. So in the case that we set I equal to 5, and we said, hey, we want to do the code block when I is greater than 10, well, 5 is not greater than 10. That condition in here would evaluate to be false, and we would not do the code block. We would continue running our code from line 12 and down. Good question. And over here, we have an example of how to loop backwards. We're now starting the number at 5, and we're saying we want to continue while that number is greater than or equal to 1. And after we do some work, we want to decrement the number. So we're going to start I is 5. We log it out. We decrement it to 4. 4 is still greater than or equal to 1. So we continue this process until we eventually hit 0, which will fail the condition over here. 0 is not greater than or equal to 1. And the code would resume from line 5 down. So it's important to know that we can kind of do whatever we want in any of these expressions. You have a lot of freedom there, and you'll find ways to get creative or cute in the future. But for now, it's more important to know that we don't always just have to do a plus plus or a minus minus. In this case, they want to loop through the numbers 100 to 300, but they actually want to increment by 100 every time and just log out 100, 200, 300. So instead of incrementing I with just plus plus, they're saying, hey, I is now equal to itself plus 100 every time. So 100 is less than 300. We'll log out 100. We'll increment I by another 100, and it'll become 200. 200 is still less than 300, so that work will continue 3 times as well. So if we said I plus plus in this case, then we would start at 100, we'd log out 100, we'd increment I with I plus plus means I is now equal to itself plus 1. So we'd go from 100 to 101, and then to 102. And that would work great. It would go through 100 through 300. We just have a lot more logs up on the console. And in this case, for whatever problem they're trying to solve, they only cared about even 100 even 100 numbers, I don't know, every 100th number is what they're looking for. Oh, over here we have another similar example where they've got a string of letters and they want to loop through the letters. So they're actually doing one of my favorite things. This is really annoying to type the brackets and to plug the I in. Basically what they're trying to get at is they want to grab the current letter. So rather than type this out once and then type this whole thing out again somewhere else and in another console log, they're just going to access letters at the ith index and they're going to save that as current letter. So when I is equal to 0 and we plug 0 into letters, this bit right here is going to evaluate to the string A. So A will be inside the current letter. Now when we come down to 6 and we want to log out what current letter is, its current value is going to be A. So I call this kind of actively debugging or like preventing errors. And my example over here, because I have alphabet index down here 3 separate times, it's very likely that I can make a mistake and I can typo it down here, but I leave it correct somewhere else. And this also introduces a bit of cognitive load. When I'm trying to read this, I need to consciously think about what happens when I plug index into alphabet, or what happens when I plug I into alphabet. And instead becomes a lot more readable if I said, hey, right at the start of this, my current letter is equal to plugging in the index at alphabet. And now down here, it shows that reverse string is just adding in the current letter. And that becomes a little bit more readable. I only had to figure out this logic once. I only needed to remember how to plug in the key once. And then the rest of my code is now closer to English and explains what it's doing. So I'm going to recommend that anytime we're iterating through a loop, or anytime we're using a loop to iterate through a list, the very first line, you want to pull out what the thing is that you actually care about. Pull it out, log it out, So in this case, I've just set up my loop. I call this actively debugging. I don't want to go 10 lines deep in my for loop and then find out that I'm not looping correctly and there's a hidden bug somewhere. So every time I write a line of code, I want to check it and make sure it's working as expected. So I wrote my for loop, I pull out the current letter, and then I just want to log out what the current letter is. I want to run the code, and I want to double check that. So here I see, yeah, I'm happy. I'm getting all of the letters that I care about. I actively debug this. Now I can go on and know that this code is okay, and I can try to do whatever more complex work I have later on in the code. So now that I know I got the current letter, I would put it back into the reverse string. And this becomes a bit more readable because I only needed to worry about the brackets and the index once. And as soon as I did that, I checked and made sure I was getting current letters and my loop worked correctly. So now I can do the harder stuff. But if I had some other bug in here, and now I've just typed a bunch of this, it's a little bit harder for me to backtrack and figure out where I went wrong. Because in the back of my head, I might assume this loop is completely okay. And now I'm looking on line 57 for this undefined bug. So as soon as you write your loops, check your assumptions, make sure they're working. Make sure you can access the data you want to access. And that's what I mean here. I'm accessing a current character using the index. Once I made sure I can get all of the data I want, I then do some more work. And that's going to save you a lot of time. I cannot stress this enough to actively debug your loops. And it's going to be a lot more efficient for you and allow you to catch bugs earlier. And this is something I still do professionally. Every time I write a line of code, I'm checking it before I move on. Any questions on looping through that string or what current letter is? Oh, also, I think I have flux on. One sec. So now we can learn about other ways we can get a little fancier with our for loops. So in this case, they wanted to loop through numbers 1 through 5, and they wanted to log them out. But for whatever reason, when I is at 3, they don't want to log out I. So JavaScript has another reserved word inside of it, and it's called continue. If I type continue into REPL, we'll see that it shows up blue, or that it's a specific word to JavaScript. So when we execute this loop, we're going to 1 is still less than 5, so we log it out. 2 is still less than 5, so we log it out. But when I is 3, and we'll cover what this symbol means, but it's comparing that those values are exactly the same. So when we plug 3 in here, and 3 is exactly equal to 3, we want to continue. And all that does is basically tell the for loop, hey, you don't need to do the rest of the code block. Just go increment the thing, check it again, and run one more time. So the continue lets us get out of this version of the code block a little bit earlier, and we won't log out the 3. But the code block, the for loop will continue to run, and now increment I to 4. 4 is not 3, so we log it out. We increment to 5. 5 is not 3, so we come down here, log it out. 5 becomes 6, and then we're done with the for loop. So this is something you might want to use if somebody tells you, hey, loop through all of these numbers and log out only the even numbers. Well, when you're on an odd number, you can use the continue keyword. Or you could choose to skip this bit and not use the continue, and you could choose to just increment by 2 and stick to only odd numbers. So that's where you get some flexibility with how you want to approach the problem. And so the continue keyword also works with the while loop. And it looks like we're doing a very similar example. We want to start with the number 5. We want to go down to 1 as our last number. And what they're doing over here is they're checking if a number is even. Can anybody tell me what this operator, or that symbol, what does that do in programming? Yeah, exactly. So this is called the modulus operator. And what it does is basically if I plug in the number 5 here, it's going to divide 5 by 2, and it's going to give me the remainder. So 2 goes into 5 twice, and the remainder is going to be 1. So if we have a remainder, if that's anything other than 0, it means that we have an odd number if we have a remainder. But if we don't have a remainder, it means we have an even number. So in this while loop, they're counting down from 5 to 1. And when they hit an even number, they want to continue to the next number. But unlike the for loop, where we had that nice little final expression that will be run every time, in the case that we have even numbers, we're not going to make it down here. We're not going to decrement the count. So they have to make sure that when we have an even number, we still decrement the count so that we can progress. If this line 6 didn't exist, the very first time we hit an even number, we would say continue. Count hasn't changed. It would still be greater than 1. It would still be even. We would continue again, and nothing would ever get done. So that's the trick here with the while loop, is that we have to remember to decrement every time we want the loop to actually continue so we can break out of it. Yes?
When you say nothing would ever get done, would the system just jump into line 13? Or would
No,
it
it's so nothing visual would happen in this loop, but it's not breaking any conditions. The number's still greater than or equal to 1, and every single time it's still going to be even. So it's just going to keep coming in here, saying continue, evaluate this to true, say that the number is still even, and hit continue. So the program's going to lock up. When that happens about 25,000 times, you'll get an error, and JavaScript will stop it, rather than let the program steal the machine from you and never run anything ever again. So nothing useful is going to get done, but it's still checking over and over again, possibly infinitely. What's up, Abel?
I don't think JavaScript does that. Rapid does that.
Yeah, I think you're correct. It'll just lock up if you run it on a terminal. So we also have another keyword, and this is the break keyword, which we're going to use this if we hit some case that means, hey, we don't care what the condition was. We want to get the hell out of this loop and never do it again. So in this case, we're saying that we're starting with some string called myGrade. And again, what type of capitalization is this? What is the style we write variables in JavaScript? Camel case, lowercase first word, uppercase second word, makes it a little bit more readable. And we're just saying, hey, we want to do this loop while it's true. So this loop's going to run forever. But luckily, we can use this break keyword and find a way to get out of the loop. So this is automatically true. We come down here and we say, hey, my grade is now equal to whatever it was, and smash a plus sign onto the end of it. So this plus sign gets added to the end here, and my grade now is A+. Down here we have a check that says, hey, if my length is equal to 3, I want to break. And as soon as we hit that break keyword, we're going to jump right to 11 and ignore the while loop. So the first time we add a plus in here, myGrade.length is going to evaluate to 2. There are 2 characters in that string. 2 is not equal to 3, so it won't come into this code block, and it will say, okay, is my condition still true? It is, so let's add another plus onto my grade. So my grade will now be A++, its length will be 3, and when we hit this break, we'll continue executing our program from line 11. Questions on that? Kursky.
The grade starts with A, what would be adding on plus?
Okay, so right here, there are quote marks around the plus.
Yeah. So
We're
is
taking...
Is that adding pluses?
Yes. This will loop until we get A++.
Okay, that's what I thought.
Yeah. So this is just a character. A string is defined by having quotes, single or double around it. And JavaScript knows to treat that differently than the plus it sees elsewhere in our code. Does that make sense? The break keyword also works in for loops. So in this case, it looks like we wanted to loop from 10 down to 1, and we're going to decrement that number every single time. But for whatever reason, we actually want to stop when I is equal to 7. So rather than just write our for loop correctly, we wanted to demonstrate the break keyword here. So we're going to start with the number 10. We're going to log it out. 10 is not equal to 7, so we don't do this. We come up here and we decrement I, so 10 will become 9, and we log it out. And that repeats. Then the very first time I is now equal to 7, this thing is true, so we execute the code in this code block. And when we hit this break keyword, we say, hey, we don't care about anything else in this for loop. We're done. Continue from down here. And we exit the loop. Yes. And name?
John.
John.
So, is break basically just like I made a mistake, I want to change something, but I don't want to go back and fix it original? Because for the other one, too, and for this one, if you put like eyes greater than 7, you know, you wouldn't have to put the break. Or is there an
Yes,
instance where
you're correct. We're just trying to demonstrate it here, but it's more likely you're going to use those keywords when you have some set of dynamic data and something could go wrong and you want to get out of that loop or you hit some edge case. In this case, there's no functional difference between setting this loop up to 7 or doing the break here. But I would recommend if you set up your for loop incorrectly, don't use a break keyword just to clean up your mistake. Because when I read the code, it looks like your initial intent is to go from 10 down to 1. And I will have no idea why you broke. So if you make a mistake, just go fix your for loop. This is more in the case where, let's say, we have a function that's going to start with a random number that you give me. And I'm going to multiply it over and over again, but up to 1,000. But if there was some reason I want to get out, if the number is 666, I can have a special case for that break. I don't know if we'll definitely hit 666 because I'm not going to just increment by 1 the whole time. But sometimes it might happen and I want to get out. So it's used for dynamic data when you're not handling every possible iteration the for loop has. In this case, the code's not going to change. This is always going to go from 10 to 1. So a break isn't necessary. It would be better if we just went from 10 to 7. But for purposes of demoing how it works, we're keeping it simple right now. Yes?
Are these slides you're using available somewhere?
Yes, so at the start of lecture, I showed you that little blue link when we go into workshop, and you click download the whole course here. Click the blue here, and you'll get a folder that has each of the workshops, each of the problems, and the slides. But at the end of class, I'll drop the slides into Slack as well. I think I did it yesterday, maybe not. But and today's lecture is also being recorded, so I'll drop a YouTube link in at the end of class as well. If you ever don't see that, somebody just ping me first, whether it's in the channel or message me directly, and we'll fix it ASAP. Speaking of which, show of hands, how many read the pre-reading today? Or watched the video? Cool. How many people were able to find the solutions last night? Okay, cool. I guess they might not be too useful if you felt very confident with your formatting, but that's definitely something we're going to want to check out again tonight. So debugging. Developers spend way more time debugging code than writing it. So let's review some techniques to help you write better code more quickly throughout the remaining workshops. My #1 favorite is as soon as we set up a loop, before we try to do any work, make sure that you're correctly looping through the data that you want to loop through. Console log it out and make sure that's all good. If you need to access some data and you need to plug an incrementer into some list, do it once and then save that in a variable and log it out so you can reuse it. Just like when we did with the current letter was equal to alphabet I. Rather than have alphabet I 10 more times throughout my code, I put that cognitive load on the reader as well as opening yourself up to mess it up later on. So this printout over here is somewhat similar to what you'll see in CodePen. When you run your code and a test spec is failing, you'll see the name of the problem set, which in this case is only odds, and then you'll see that little description block for the test that ran. So in this case, only odds should have returned a number, but that test case threw an error where it said sum is not defined. So it means over here, reference error, the category of error, means that the code tried to refer to some variable that didn't exist. So the test case assumed there would be a variable called sum, but there never was. And when it went to access it, JavaScript throws an error and says, hey, the thing you're trying to find, you never told me to care about a sum. I have no idea what to do. I'm going to stop your program. And now down here we have what's known as the call stack. This is basically a list of all of the functions that have run to get us to that point. Now, in our case, when we're only writing about 1 or 2 functions deep, we're probably only going to care about the top of the call stack. So in this case, it's saying, hey, at the only odds function, there was an error in this file on line 11. And this sometimes means the character at which it thinks the error went wrong. So this is saying at the 7th character of that line. We might have tried to refer to a variable called sum, and it didn't exist, so we threw an error. Then, because only odds was probably the only function that we defined and were running, the rest of the call stack is about what is actually running our code. So in Jasmine or the test specs, these functions down here are probably related to the actual testing library themselves. Most often, you're only going to care about the first line, and you're going to want to hone in on whatever line it says the problem went wrong on. That won't always be 100% accurate, depending on what exactly happened. JavaScript might not know where it went wrong, but it's in that general area, and something prevented it from moving forward. So that's a good place to start. Any questions on the call stack or the line or how to read this error? Definitely gets easier with the experience, especially once we get deeper into functions. But for now, you should be able to have a general idea of what type of thing went wrong and where you can begin to look for it. So again, note the stack trace below the error. It's saying the first at over here is the line that gives the location where the error occurred in the file. So it's saying, hey, this function inside of this file, only-odds.js, had an error, and it looks like it happened around line 11 and possibly at character 7. So the line number may not always be accurate, but it's usually a great place to start. It's going to be somewhere around there. And if you ever have an error that you have no idea what it means, we need to fill in the blanks. And if nobody's there to tell you what went wrong, and you're a good programmer, you want to be a better programmer, you're going to Google it and try to figure out what went wrong. Because chances are nowadays, I think developers use Google more than any other profession or the average person. So any question you have in JavaScript, it's been asked before. Try to get aggressive with putting things into Google, and you're going to get a little bit better at honing in on exactly what you're looking for, and you're also going to get to shortcut to whatever knowledge you find out there, rather than just repeating the same mistake over and over again until it clicks. So when your test is failing, but the code didn't actually return an error, you'll get an output that compares the value your function returned against what the test was expecting to get. So in the case that we ran only odds, and on the test case that expected the function to return the sum of all odd numbers between the provided argument and 0, they were expecting to get the number 25, but your code produced the number 55. So this isn't actually a JavaScript error, it's the test library throwing an error and telling you, hey, we didn't get what we were looking for, and you're going to want to look at the logic of your code and try to figure out how you got 55 when you know that your target is 25. Do we see the difference between this type of error and this one over here? This is a native JavaScript error the code couldn't run. Whereas this is an error that the programmers defined to throw and give you a description of why they stopped your code. So they look a little bit different. So note that the plain English explanation, this thing here, that was in all those strings of the code blocks we looked at briefly yesterday, should describe a little bit of what the test is looking for. I cannot stress enough that it will really help you to start scrolling down to the test specs, reading what they're actually trying to do, because it will help you form a solution a bit better. And as we get more comfortable, it's even better to read the code inside of the test spec to see what they're doing to cause a problem. They may pass some data into your function that you didn't expect and you didn't think you needed to handle an empty string. But when you look at the code block and you see they called your function with an empty string, that gives you a hint towards an edge case that you need to fix. Does that make sense? We'll have a visual of the test specs again in a couple slides. So in this case, if your test is failing with undefined outputs, make sure you're actually returning a value out of a function. So what I mean by that is, and I'll send this REPL out at the end of class as well, even though I've made a mess of it. So pretend we have a function down here. I want to know what this function evaluates to. So I'm going to invoke it on line 75. And what happens when we hit this line is it says, hey, go find the bit of code or the recipe that somebody told JavaScript should be known as return something. JavaScript's going to find this function that's going to say, okay, so I need to execute the code that was in between these blocks. The only thing I'm doing here is I'm returning a value. Now, whatever gets returned, when we're in a function, as soon as we hit a return keyword, that function will stop. It doesn't matter if I have code at the end of that function. You're not going to see it. Just like the break keyword, if we hit a return in a function, that function ends. And this call down here will evaluate to whatever value got returned from the function. So you can imagine after JavaScript runs the code, it's just going to plug in a little 10 down here. And that's why we saw a 10 pop up as the value of the last evaluated line. So now in the case that I don't do anything inside of my function, JavaScript will actually automatically at the end of your function do this and return an undefined value. We see that the blue keyword means undefined is a special word to JavaScript. And you won't see this, but if I run this code, that function did run. We did come in here and do nothing for 3 lines. So JavaScript returned undefined to be the value of what this call was. And so we see undefined pop up in green over here. And now a lot of beginners make the mistake where they want to log out whatever their number was. And so they'll log something out over here. And they'll fail the test case. And they're like, hey, I'm doing the work correctly. I got the number 100. Why is my test spec failing? That's because they forgot to do return 100. So they were actually returning the value undefined. So that's something to keep an eye out for. And as another example, console.log is a function, and it takes a number, but console.log, the actual JavaScript function, doesn't return a value. So when the last line that we ran is console.log, that function doesn't return a value. So this line actually resolves to undefined. And that's what we see in green as the output, as the evaluation of the final line in our file. That will get a little bit easier when we talk more about data types and what exactly undefined is. But it's very important to realize that if you don't have a return keyword, your function is going to evaluate to undefined. It doesn't matter what you put out on the console. This is purely only for humans. The test library is not going to see it, and the rest of your code doesn't care. So when we see this error, expected undefined to equal number, it means your function is probably not returning anything, or it returned a variable that didn't have a value. So lastly, it can also help to look directly at the code that defines how the test is supposed to work. When you scroll to the bottom of your file, you'll see these little it blocks that are describing the name of the problem. Remember at the top there'll be something that says describe only odds. Then there's going to be a bunch of its that say, hey, only odds returns the sum of all odd numbers between the provided argument and 0. This is the exact description we saw pop up in the output when our test failed. And now if we look over here, this is just a syntactic sugar for a function. The test library is putting a function in here that should get run when it wants to check if this thing is correct. So it's just going to execute this code over here, and it's saying, hey, I'm going to call your only odds function with 10. I'm going to save it as return value. And the test library, when it does this expect, it's expecting the returned value to be equal to 25. And if it's not, that's when you'll see that error pop up and say, hey, we expected 100 to be 25. So in the case that you hit one of those where you're not putting out the correct output, it would really help you to come down here and say, okay, well, what did they call my function with? Because now you can go read your code again and be like, all right, why did the number 10 not resolve to 25? And it gives you a starting place rather than bashing your head against the wall trying to guess randomly. Does that make sense, how to read what's going on down here? Even if we don't understand the symbols, you can kind of read the description and try to read this code to see how they're using your code. Yes?
What would be the name of that function?
This type?
Yeah.
It's called an arrow function. and it's a new, it was recently added to JavaScript. And while it looks really ugly at first, it allows us to be a little bit more concise, and we can do some really cool things, like have a function that returns a function that returns a function, all in one line. So I'll show you that when we get to it, but it's a bit more mathematical, and it's just sugar. It just makes it a little bit easier to read when you're used to it. No real difference you need to be aware of yet. And what was your name? Javier, thank you. Yes, Ryan.
On this slide, you were saying how people don't usually think, or beginners don't usually think that debugging is plain JavaScript, but it is. But he was saying that line 14 is not JavaScript. What is that?
Yeah, okay, so this expect keyword here and the it, those are functions that were defined in the testing library that we ran. So the testing library has a function that takes this value, and then it checks against this value, 25. And if they're not equal, that's what threw the error to say, hey, we expected x to equal y. So that only belongs to the testing library. We just have to be able to glance at it and have an idea of what's going on, but that's not part of native JavaScript. So one of the reasons JavaScript is so great right now is that we have what's called NPM, or it's this, you can imagine the cloud, right? All these developers work on a bunch of different problems, and when they have a solution, they store it up in the cloud for other developers to download and to use that JavaScript in their programs. So they're called libraries, and we're using a library that somebody else built to test your code. And JavaScript has the largest library manager of these packages, and it really speeds up our development. But I think I mentioned yesterday, there was a time when half the internet was dependent on this one very small function that all it did was pad out a string with, if you had a bunch of numbers, it added zeros in the front. Somebody changed one line of code on that, and it turned out that half the internet was using that library no matter how small it was, and when that broke, half the web went down for that day. So it has its quirks, but more often than not, having access to so many great packages means that you don't really have to reinvent the wheel. And that's why when we become better developers and we're not just working on the very basics, we can Google our problem and see that somebody else has already solved it, read their documentation, use their solution, and now we get it done in half the time. So we're using a testing library behind the scenes, and that's what it and expect come from. They're not native JavaScript keywords. So now the takeaway here was that we saw that they're passing the number 10 to your function, and now that gives you a hint on where to possibly clean up your function and make it work for the number 10. Lastly, all of the code inside of the tests, besides the line that starts with expect, is plain JavaScript. So let this equal whatever, this function, this is normal JavaScript, and aside from this expect block, this is also normal JavaScript. Really just line 13, that's not really a great statement. So we looked at while loops. We did not look at a do while, so we'll go do that real quickly. We looked at for loops, the break and continue keywords. What does break do? If we hit break, what happens? Loop stops and it starts, the code continues where? Right below the code block. And if we have a continue, what happens in a loop? Skips, and if we're a for loop, we're going to do our incrementer, check the condition, and then run the code block again. We talked about how to interpret stack trace error messages, how to debug a test, and I spoke of how to actively debug your loops. So real quickly, what is a do while loop? Let's say that we had the number 1. And for some reason, we wanted to do some work while x is greater than 10. But this is basically just a while loop flipped on its head. This is in the do while loop, we're going to do the code block first. Then we're going to check the condition. So while my condition says to continue to do this thing while x is greater than 10, 1 was never greater than 10. But the do let us do this at least once. So we logged out what the number was. The while loop evaluated to false. We do not run the code block again. This isn't that important right now. You can get everything else done with a while loop and a for loop, but there may be some times you want to do code anyway and then check if you should continue. So that's the difference between the do while and the normal while loop. If this was just while x is greater than 10, this doesn't happen at all. Does that make sense? All right, any final questions? Okay, cool. Take a 5-minute break. I'll put the pairs out in Slack. I'll send the video out by the end of class. And then make sure you begin to use those help tickets. I don't think we had any yesterday, but you'll definitely want to click the blue button and get help as soon as you're having problems.